Welcome to this Maths Made Easy video on presenting data. To start with, let's take a look at bar charts. Now, one way to represent data is a bar chart, where the height of each bar represents the data point for each category. So if we take a look at this example here, for category A, our data point is A of whatever category A represents. For B here, category B, that would be 4, for category C that would be 2, and for category D that would be 6 there. Okay. And we can note here that bar charts come in many different forms, including with bars placed horizontally instead of vertically, or even, like we can see here, with lines instead of bars. So that gives us everything we need there for bar charts. Moving on now to stem and leaf diagrams. Now, stem and leaf diagrams are another way of representing data. It allows raw data to be listed in a space efficient way. The single digit behind the line represents tens or hundreds, etc., and the digits after the line represents the actual value. So here, it's easy to see with an actual diagram. So using this diagram here, the 2 and the 9, as we're told using the key here, represents 29. So the 2 there represents the 20s, the 3 here represents the 30s, so for example, 3 and the 1 would be 31. 3 and the 6 would give us 36, and the 8 and the 0 would give us 80 there. Now, this would here represent the scores of a maths test for, say, Class C. So that means one person got 29, one person got 31, one person got 32, one person got 36, and so on. Now, it's important to note here that we can't forget the key, as we can see in this diagram. If we do forget the key, we will lose a mark, so it's very important that we don't forget the key. Now, stem and leaf diagrams can also be double-sided. So, for example, if we want to, compare the scores between two classes, then we can use a double-sided stem and leaf diagram. Where, for example, here, this would represent Class H, and this would represent Class C there. Okay. So that gives us everything we need there for stem and leaf diagrams. Moving on now to take a look at measures of central tendency from stem and leaf diagrams. Now, stem and leaf diagrams provide us with all of the raw data, so in that case, it's simple to calculate the mean, median, and mode from this. All we need to do is write it out as raw data and then use that data. So for example here, if we consider again this example with Class H on the left and Class C on the right. What we want to do now is check the mean for each class. So here, using both classes, to check the mean, all we would simply do is tally the scores here from Class C. So that's going to be 29 plus 31 plus 32 plus 36 all the way up to plus 80, and we divide that by the total number of scores here, which in that case is 23. So the mean for Class C, is equal to 29 plus 31 plus 32 plus 36 plus 41 and so on. Well, we divide this, like we said, by the total number of scores here within the class, which was 23. So if we evaluate this on our calculator here, what we get for the mean of Class C is 52.26 there. And if we do this for Class H now, we can get the mean for Class H, and then we can compare the means. So the mean for Class H, again, follows a similar pattern. We just need to add up all the scores and divide by the total number of scores. So here this would start as 21 plus 32 plus 34 plus 37 plus 38 and so on. Okay. And again, we divide this by the total number of scores, which is again 23. Now if we evaluate this on our calculator, what we get here for the mean of Class H is 43.30. So what that tells us then is the mean for Class C is higher. We can also find the median of Class C, and conveniently, the stem and leaf diagram already provides our data in order, so we don't need to sort that in order. We can work on it as presented to us, and one method is to cross the highest and lowest value off simultaneously, then the second highest and the second lowest, then the third highest and third lowest, and so on. So that would look like this, for example. So we cross off the lowest and the highest, we then cross off the second lowest and the second highest, and again we would just keep repeating that. Okay. And what we'd find here is the median for Class C is 52. So median for Class C is equal to 52. And finally, the mode of all marks can be found with ease. Again, since we're presented with the raw data, we can see clearly which number appears most often. And in that case, the mode is 41, which appears 5 times, 3 times in Class H and twice in Class C. Okay, so the mode is equal to 41 there. So that gives us everything we need there for measures of central tendency from stem and leaf diagrams. Finally, let's take a look now at histograms. Now a histogram looks like a bar chart, except the columns can be different widths, and we plot frequency density instead of frequency. And we can see an example of that here. So notice again, this is frequency density rather than frequency. In histograms, the area of each rectangle tells you the frequency of the data class, with the width of rectangles usually indicating the size of the data class they represent. So this gives us a formula that we can use. And the formula here is frequency. So frequency is equal to class width, so class width times by frequency density. So frequency density. So again, just to reiterate that, the frequency is equal to the class width times by the frequency density. So if we take a look at this example here, we've been given our data with our class width here for our class, which we can obviously work out the class width then, and our frequencies. Now the first class has a width of 10, 0 to 10. So the rectangle in the histogram should have a width of 10, which we can see here, and it has a frequency of 6. So the rectangle in the histogram should have an area of 6, so this means that its height must be 0.6, which we can see here. Okay, so that's 0.6 there. The second class has a width of 10 as well, so the rectangle in the histogram should have a width of 10. It has a frequency of 15, so the rectangle in the histogram should have an area of 15. This means that its height must be 1.5, and again we can see that here on our frequency density. The third class has a width of 4, so the rectangle in the histogram should have a width of 4. It has a frequency of 16, so the rectangle in the histogram should have an area of 16. This means that its height must be 4, which we can see on our histogram here. And again, measuring across on the frequency density, we can see that there. The fourth class has a width of 6, so the rectangle in the histogram should have a width of 6 as well. It has a frequency of 21, so the rectangle in the histogram should also have an area of 21, and this means that its height must be 3.5, which we can see on the histogram. And finally, the fifth class has a width of 15, so the rectangle in the histogram should have a width of 15. It also has a frequency of 15, so the rectangle in the histogram should have an area of 15. This means that its height must be 1, and finally we can see that again on our histogram there. So that gives us everything we need there for histograms, and that concludes this Maths Made Easy video on presenting data.